Okay, Xavier,
Yeah.
we are on.
Oh, perfect. I'm trying to find the link here. Oh, how can I share the link with people? I need to click on the.
You just go
Ah,
to the first
okay.
page, and there is a box.
Ah, I found it. If you want to introduce the live,
Yes, of
uh,
course. So, hello, ladies and gentlemen. Please welcome me to this live. We are talking about the Artemis mission. Last live we watched together the launch, and today we talk about the technical uh, the technical issues. Uh, we will go in depth, far in depth. But before we start introducing my great, my great Vice President Flavia Chicago. Uh, Let me update you uh, that the onion, the onion capsule is uh, is uh, is flying is flying the moon's surface, and the crew but it's taking geological studies of the moon's surface. If this they are specific, even the sun corona, the the most atmosphere of the sun, and maybe maybe we are planning to make another life uh, towards the the the, the landing of Artemis. So I leave now the points to Flavia, and let's give her an applause. So Flavia, let's go.
thank you, Gerd, for such amazing introduction to this live and the presentation. I'm very happy to be here today with Gerd, the president of Free Astro Science Channel, a very strong man and very intelligent. So
Come
I will share my PowerPoint, and I want to update all of you about the mission. Um, let's check here. Okay.
That's
Mm,
big.
good. I will introduce myself briefly. My name is Flávia Secato. I live in Brazil. I'm Brazilian and Italian. I have a background in physics, and I also hold a postgraduate degree in astronomy education. which has allowed me to connect scientific knowledge with broader perspectives on how we understand the universe. Today, I will be sharing insights about one of the most important missions of our time, Artemis 2. My goal is to present the technical aspects of the mission and also bring you the most recent updates, since this mission is currently unfolding in real time. Artemis 2 represents a moment that has been a long time coming. For over 5 decades, human spaceflight has remained within low Earth orbit. During this time, we made remarkable progress building space stations, advancing technologies, refining operations, but always staying relatively close to Earth. This mission changed that trajectory. With Artemis 2, astronauts are once again traveling beyond low Earth orbit, something that has not happened since the Apollo era. The mission itself is relatively short, about 10 days, with a crew of four, but its significance goes far beyond those numbers. It's part of a broader effort to develop the capabilities needed for sustained exploration, not just for short visits, but continuous presence. Every system on board is being tested with that future in mind: life support, navigation, human performance in deep space. In many ways, this mission reconnects the present with a path that was paused decades ago and sets the foundation for what comes next. To understand the importance of Artemis, it helps to look at the bigger picture. Returning to the moon is one part of it, of course. Humans haven't been there since 1972, and going back already carries historical weight. But this time, the objective is different. The idea is to create conditions for continuity, not just short visits. There is also a strong focus on building a long term presence. That means developing infrastructure, learning how to operate in that environment over extended periods, and gradually turning the moon into a place where missions can be sustained. Another key aspect is its role as preparation for Mars. The moon works as a testing ground, close enough to manage risk, but still challenging enough to simulate deep space conditions. And finally, there is the international dimension. Artemis brings together multiple space agencies, each contributing different technologies and expertise. Among them, the European Space Agency is responsible for key components such as the Orion service model and elements of the gateway, including habitation and communication systems. The Japan Aerospace Exploration Agency contributes critical life support, components, batteries, and the logistic capabilities, as well as future mobility systems for the lunar surface. The Canadian Space Agency is developing advanced robotic systems, including the Canadarm3, which will play a central role in operations around the moon. The Mohammed bin Rashid Space Center from the United Arab Emirates is contributing the crew and science airlock for the gateway, enabling both astronaut activities and scientific operations in deep space. In addition to these, astronauts from these agencies will also take part in future Artemis missions. Alongside international partners, there is also a vast industrial ecosystem. Major space companies such as Boeing, Lockheed Martin, Northrop Grumman, and SpaceX are supported by thousands of suppliers, um, working on everything from propulsion systems to life support and surface mobility. What makes this particularly interesting in the level of integration required? Different countries, different systems, all operating within a single mission framework. This reflects a broader shift in space exploration toward a model that is inherently global, interconnected, and built on shared capabilities. This timeline helps put Artemis 2 into perspective. Between 1961 and 1972, during the Apollo program, human space exploration advanced at an extraordinary pace. In just over a decade, we went from the first human spaceflight to landing on the moon. 12 astronauts walked on the lunar surface, and that period defined what was technologically possible at the time. Then something interesting happened. After Apollo 17 in 1972, human missions stopped going beyond Earth orbit. For more than 50 years, space flight continued, but within a very different scope. The focus shifted to low Earth orbit, with programs like the Space Shuttle, the International Space Station, and earlier stations like Mir. This phase was not a pause in progress, but a change in direction. It allowed us to develop long duration missions, refine life support systems, and build experience in orbital operations. Now, with Artemis, that trajectory expands again. What we are seeing is not a restart, but a continuation, built on decades of accumulated knowledge, now extending once more into deep space. When you think about Apollo, it's impossible not to remember the context of that time. There was a strong sense of urgency. The space race was unfolding in the middle of the Cold War, and reaching the moon became a symbolic and strategic objective. Everything moved very quickly, and the results were extraordinary. Uh, but that pace also meant the program wasn't designed for continuity. After a few successful missions, it simply ended. The president at that time was John Kennedy. In 1961, during the height of the Cold War, he set a clear national goal to land a man on the moon and bring him safely back to Earth before the end of the decade. This decision was strongly influenced by geopolitical competition with the Soviet Union, especially after milestones like Yuri Gagarin's flight. Even after Kennedy's assassination, the program continued under Lyndon B. Johnson, who ensured the political and financial support needed to make the moon landing possible. Today, the environment is different. Artemis is being developed more gradually with a longer horizon in mind. The idea is to build something that can be maintained and expanded over time. There is also a broader participation now. Different space agencies are involved, like I said before, contributing specific parts of the mission, which reflects a more collaborative approach. So when we look at this transition from Apollo to Artemis, it feels less like a repetition and more like a new phase, one that is being built step by step. Nowadays, we have a competition between United States and China. China is doing everything alone, this path toward the moon, but US has several partners in collaboration. This is the main difference between both countries. Talking about Artemis also means talking about cost because missions at this scale require a significant level of investment. There isn't a single exact number publicly available for Artemis 2 alone, but current estimates suggest that each launch costs over $4 billion. Dollars. This includes the Space Launch System rocket and the Orion spacecraft, which are both extremely complex and designed for deep space missions. When we look at the broader picture, Artemis 2 is part of a much larger program. The total cost for the Artemis program is estimated to be around $90 billion dollars, or over more than a decade of development. Most of this funding comes from the United States government through NASA's budget approved by Congress. In practice, that means the program is largely funded by American taxpayers. At the same time, private aerospace companies play a major role. As I mentioned before, companies like Boeing, Lockheed Martin, and Northrop Grumman are responsible for building key components such as the rocket and the spacecraft working under government contracts. So, what we see here is a model where public funding and private industry are closely integrated, combining resources, expertise, and infrastructure to make missions like Artemis 2 possible. This slide gives a quick sense of how the Artemis program is structured. It begins with Artemis 1, which was an uncrewed mission. The main objective there was to validate the Orion spacecraft in deep space conditions, testing navigation, communication, and especially re entry at very high speeds. Then comes Artemis 2. We are now in this phase, which is This is the first crewed mission in the program. Instead of landing, the focus is on taking astronauts around the moon and bringing them safely back, while testing all the human related systems in a real deep space environment. The next step is Artemis 3. That mission is planned to take humans back to the lunar surface, something that hasn't happened since the Apollo era. So there is a clear progression here. Each mission builds on the previous one, gradually increasing complexity and reducing risk. It's a very deliberate approach, moving step by step, making sure each element works before advancing to the next stage. Before sending astronauts, NASA needed to make sure everything worked in real conditions. And that was the whole of Artemis 1. This was an uncrewed mission, as I said, launched in November 2022, designed to test the entire system in deep space. One of the key achievements was the performance of the Orion spacecraft itself. It traveled farther than any spacecraft built to carry humans had ever gone, completing a long duration mission and returning safely to Earth. The heat shield was another critical element during re entry. It had to withstand extremely high temperatures, close to 5,000 degrees Fahrenheit, and it performed exactly as expected. That's essential because this is what protects the crew on the way back. Navigation and communication systems were also tested throughout the entire trajectory. Operating far beyond low Earth orbit introduces different challenges, especially in terms of signal delay and precision, and the systems remained stable within their expected parameters. So by the end of Artemis 1, there was a solid level of confidence that the core systems were ready, which is what makes Artemis 2 possible now. This mission is very focused on testing, especially in conditions that can't be fully reproduced on Earth. One of the main priorities is the life support system. For the first time, it will be operating with a crew on board in deep space, which is a very different environment compared to low Earth orbit. Everything related to air, water, temperature, and pressure has to remain stable over the entire mission. There is also a strong emphasis on understanding how the human body and mind respond to this type of flight. Deep space introduces different stressors, including radiation, isolation, and distance from Earth, so monitoring the crew becomes an important part of the mission. Another key aspect is navigation and control. The spacecraft will operate both autonomously and with manual input from the astronauts. This includes trajectory adjustments while traveling far from Earth, where communication delays become more relevant. So, overall, Artemis 2 is about making sure that all these systems, technical and human, can work together reliably in deep space. This timeline becomes clear when we walk through the mission step by step. It starts with launch when Orion lifts off aboard the Space Launch System. Within a few minutes, the core stage separates and the spacecraft is already in space. Soon after, Orion deploys its solar arrays, which will provide power for the entire mission. In the first phase, the spacecraft remains in Earth orbit. The crew spends about a day there checking systems and even manually flying the vehicle to evaluate its behavior in real conditions. Then comes one of the key moments, the translunar injection. This maneuver sends Orion out of Earth orbit and onto its path towards the moon. The journey takes about 3 days with continuous system monitoring and communication through NASA's Deep Space Network. Around days 5 and 6, Orion reaches the lunar region. The moon becomes the main gravitational influence, and the spacecraft performs a close flyby, passing behind the moon and reaching its maximum distance from Earth. From that point, the crew can see both the moon nearby and the Earth far in the background. After that, the mission transitions into the return phase. Orion uses the moon's gravity to redirect its trajectory back toward Earth, minimizing fuel use. In the final days, the crew prepares for re-entry. The spacecraft enters the atmosphere at very high speed, generating intense heat, before deploying parachutes and landing in the Pacific Ocean, where recovery teams retrieve the capsule and the astronauts. So, in just about 10 days, the mission covers the full cycle of a deep space flight from launch to return, while testing every critical system along the way. One of the most elegant aspects of this mission is the trajectory itself. Artemis 2 follows what is known as a free return trajectory. In simple terms, this is a path that takes the spacecraft around the moon and naturally brings it back to Earth using gravity rather than relying entirely on propulsion. This is not a new concept. It was also used during Apollo missions, but it remains a very important safety feature. The idea is that even in a situation where the propulsion system doesn't perform as expected, the spacecraft would still return to Earth without requiring major corrections. So instead of depending only on board systems, the mission design takes advantage of the gravitational interaction between the Earth and the Moon. From an engineering perspective, this reduces risk in a very fundamental way. It's a good example of how mission planning combines physics and safety, designing a trajectory where if something goes wrong, the system still has a built-in path back home. This is the Space Launch System, or SLS, the rocket responsible for sending Artemis 2 into space. In terms of raw capability, it's currently the most powerful operational rocket in the world. It generates around 39 meganewtons of thrust, which is enough to push a fully loaded spacecraft beyond Earth's gravitational influence and toward the moon. The structure itself is also impressive. At nearly 100 meters tall, it's taller than the Statue of Liberty, which gives a sense of the scale we are dealing with. At its core, the rocket uses four RS 25 engines. These are not entirely new, they are based on engines originally developed for the Space Shuttle, but upgraded and adapted for this mission. That reuse of proven technology is intentional, especially for crewed flights where reliability is critical. The central stage runs on liquid hydrogen and liquid oxygen, combined with two solid rocket boosters. This configuration provides both the sustained thrust and the initial power needed to leave the launch pad and accelerate into space. So the SLS is not just powerful, it's also the result of combining legacy technology with new engineering designed specifically for deep space missions with human crews. This is the Orion spacecraft, which is where the astronauts actually live during the mission. It's divided into two main parts. The crew module is the section that returns to Earth at the end of the mission. It houses the astronauts, the control systems, and the head shield that protects the vehicle during re-entry. Inside, the space is relatively compact. There are four seats, a central control interface, windows for visibility, and basic systems to support the crew throughout the mission. Everything is designed to be functional and efficient given the constraints of space travel. Attached to it, the service model, which is provided by the European Space Agency. This part is responsible for propulsion, power generation, and consumables like oxygen and water. It also includes the solar arrays that supply energy during the entire journey. One of the most critical features of Orion is its head shield. It's the largest ever built for a spacecraft designed to carry humans, and it has to withstand extremely high temperatures during re-entry. So Orion is essentially a self-contained system, a small controlled environment capable of sustaining human life while traveling far beyond Earth orbit and safely bringing the crew back. In deep space, survival depends entirely on the spacecraft. Inside Orion, the crew is essentially living in a closed environment where every element has to be controlled: air, water, temperature, everything. The oxygen system continuously supplies breathable air, while carbon dioxide is removed to keep the atmosphere stable. Even small variations here can become critical over time, so the system has to operate with a high level of precision. Water management is another important part. There is a limited supply on board, so efficiency is key. The system tracks usage carefully and, whenever possible, reuses resources to make sure the crew has what they need throughout the mission. Temperature control is also more complex than it might seem. In space, the spacecraft can be exposed to intense sunlight on one side and extreme cold on the other. The system has to balance that and keep the interior within a narrow, comfortable range. What makes all of this challenging is that it has to work continuously without interruption and with limited possibility for external intervention. So, in a way, the life support system is what turns Orion into a livable environment, a small, controlled space where human life can be sustained far beyond Earth. One of the less visible but most important challenges in deep space is radiation. While astronauts are in low Earth orbit, they are still partially protected by Earth's magnetic field. Once they move beyond that region, that protection is no longer there. At that point, they are exposed to two main sources. One is galactic cosmic rays, which are high energy particles coming from outside our solar system. The other is solar particle events, which are bursts of radiation associated with solar activity. These are not constant in the same way. Cosmic radiation is always present, while solar events can occur suddenly and with much higher intensity. Because of that, the mission includes several protective strategies. Inside Orion, there is a designated area that can be used as a storm shelter during periods of higher solar activity. The crew is also continuously monitored, so exposure levels can be tracked in real time. Mission planning also plays a role. The duration and trajectory are designed to limit exposure as much as possible. So, even though radiation cannot be eliminated, it can be managed. And understanding how to do that is essential for future missions, especially those that go farther and last longer. Navigation in deep space is quite different from what we are used to here on Earth. Since there is no GPS available, the spacecraft has to determine its position using onboard systems. One of the main tools for that is star tracking. By observing known stars and comparing their positions, the system can calculate orientation and trajectory with a high level of precision, even at large distances. These measurements are supported by optical navigation cameras, which help refine position estimates as the spacecraft travels toward the moon. At the same time, a large part of the operation is handled autonomously. The onboard computers can perform trajectory corrections, control orientation, and manage different systems without immediate input from Earth. This becomes especially important because communication delays increase as the spacecraft moves farther away. Even so, the crew is not passive. One of the objectives of Artemis 2 is to test manual control in deep space. The astronauts can take over certain functions and actively guide the spacecraft if needed. So there is a balance here: automated systems handling routine operations and human intervention available when necessary. That combination is essential for future missions where both precision and adaptability will be required. This is where the mission stands. I don't believe right now, but until this morning when I finish this presentation. After launch, Orion successfully reached its planet high Earth orbit. This is an important confirmation point. It tells us that the rocket performed as expected and that the spacecraft is operating within its normal conditions. From there, the mission moved into what we call orbit shaping, a key maneuver. The perigee raise burn was completed to adjust the orbit and position the spacecraft precisely for the next major step. That next step is the translunar injection, which is essentially the moment when Orion leaves Earth orbit and begins its journey toward the moon. At this stage, both the crew and the ground team are focused on preparation. Everything has to be carefully verified before that burn is executed because it defines the trajectory for the rest of the mission. So, what we are seeing here is a sequence of controlled incremental steps, each one confirming that the mission is progressing as planned and setting up the transition from Earth orbit into deep space. Inside the spacecraft, the crew has already shifted into operational routine. They are conducting onboard activities, including physical exercise using a compact flywheel system. In deep space, maintaining physical condition is essential, especially with limited equipment and space constraints. At the same time, systems continue to be closely monitored. Life support performance, spacecraft dynamics, and even how crew movement affects the vehicle are being evaluated in real time. There was also a brief communication interruption earlier, which was quickly identified as a ground system configuration issue and resolved without any impact. The team was preparing for the lunar flyby. In this image, a detailed observation plan was being developed, including geological targets on the moon and even a planned solar eclipse observation during the pass. This mission also carries a symbolical milestone. During the lunar flyby, the crew is expected to reach a distance of around 400,000 kilometers from Earth. That places them at the edge of what humans have ever experienced in space. It's been more than 50 years since astronauts last traveled this far. Since then, human spaceflight has remained relatively close to Earth. There is also the possibility of setting a new record. The current one was established during Apollo 13 when the crew reached the greatest distance from Earth, not by design but as part of an emergency trajectory. Artemis 2 approached that same threshold under completely different circumstances through careful planning and controlled execution. So, beyond the technical goals, there is a historical dimension here. This mission reconnects the present with a moment that defined the past and extends it a little further. Artemis 2 is also an important scientific mission. Even though it doesn't land on the moon, it creates a rare opportunity to study how humans and biological systems behave outside Earth's protective environment. One of the key areas is radiation measurement. By tracking the dose received by each crew member, scientists can better understand exposure levels in deep space and refine protection strategies for future missions. There is also a strong focus on human physiology. The mission allows researchers to observe how the body responds over time, including cardiovascular adaptation, balance, and cognitive performance, all in conditions that are very different from low Earth orbit. In parallel, biological experiments are being conducted to study how living tissues react to radiation and microgravity. These results are important not only for space exploration but also for medical research on Earth. So, while the spacecraft is traveling around the moon, it's also collecting data that will shape how we approach longer mission in the future. The mission is part of something much larger. Artemis 2 is not the final goal, it's a step toward what comes next. The next major milestone is Artemis 3, which is planned to take humans back to the surface of the moon. That will mark the first lunar landing in more than 5 decades. Beyond that, the plan includes the Lunar Gateway, a space station in orbit around the moon. It will serve as a staging point, allowing missions to operate more efficiently between Earth and the lunar surface. Over time, these elements begin to form a more permanent presence. Infrastructure, habitats, and systems designed to support longer stays and more complex operations. And from there, the trajectory extends even further. The moon becomes a place where we learn how to live and work beyond Earth, and that experience feeds directly into future missions to Mars. Oh, it's incredible. Um, so, as the spacecraft moves farther away from Earth, communication becomes a critical challenge. That's where NASA's Deep Space Network comes in. It's a global system of large antennas that keeps continuous contact with the spacecraft throughout the mission. These antennas are distributed in three main locations in the United States, Spain, and Australia. This positioning allows Earth's rotation to be covered at all times, so there is always at least one station in contact with Orion. Through this network, Mission Control receives a constant stream of data. That includes telemetry about the spacecraft systems, voice communication with the crew, and precise tracking information such as position and velocity. This is how engineers on the ground know exactly what is happening on board, even at large distances. At the same time, commands can be sent back to the spacecraft whenever needed. So, even though the crew is traveling far from Earth, they are never truly disconnected. The Deep Space Network is what maintains that link, enabling continuous monitoring, decision making, and overall mission safety. So I didn't finish yet. I just want to show for the crew members because it's a very exciting moment. So
Yes.
let me share the my web page here. Just a minute. Uh, Oh, this is the NASA website, nasa.gov. Meet the
Mm,
crew. This is the Ray Wiseman, the commander of the mission. He's a very experienced man commander on NASA. This is Victor Glover, the pilot. He is the first Afro American to go to the moon. It's so exciting. And this is Christina Koch. She's the first woman to go to the moon. She is the a mission specialist, and this is Jeremy Hansen. He is the first non-American. He is Canadian to go to the moon. So the crew is very eclectic. Is contains several different profiles. It's very amazing.
yes.
Let just
It is amazing, amazing,
yeah. And
amazing.
I want to share with you just a moment. I will just find the link. Uh,
Yes, of course.
of the updates of the mission. Uh, just a minute. Um,
From NASA.
uh, this is the multimedia. I want to show the multimedia first. Um, yeah,
Mhm.
just open the other window. Also
Yeah,
use it.
hope number.
Yeah, perfect.
Yeah.
Here, here, Gerd. This page, nasa.gov Artemis to multimedia. You can find several images from the crew took by the crew, um, and all the mission images since the beginning. And this is from now inside the Orion spacecraft. It's really amazing. And in this page, Artemis 2 news and updates, you can find out the last news about Artemis mission. We are in the
and
day 4, I believe, day 4 or 5.
go to freescience.com.
Yeah, let
You.
me stop my sharing.
That's a joke. That's a joke.
No, for sure, they need to go to freeastroscience.com to find out more information and explanation about
Yes,
Artemis
yes.
mission.
So, there, there was a great, super great station. Let, let, let me say that the Artemis broke the record about 20,000 miles away from Apollo, Apollo 13 trajectories. So Artemis broke the record and is the farthest object in in the human history. So never, never humans gone further than Artemis in Artemis 2 missions. This is the last update for the mission. So if you have questions, just write in the box or something else. We are available. Any questions, Flavia?
Yeah.
Check.
Oh, I appreciate a lot the invitation to do this live. Thank you so much, Gerd. And if anyone have questions,
Check.
we are available to answer those questions.
Check. Check if there is a question or not. Guys, make a question. Make question. Come on, devote.
Gerd, I have a theory. Or my presentation was so detailed that they don't have any doubt, or they didn't understand anything I said.
Or your speech was like the security cabin crew, in the plane, where the cabin crew talk about the safety measurement. Do you know, Flavia?
Do you want to know about the safety against radiation? You mean?
No. No. I say that your
My
speech
speech. What?
is is like the cabin crew security in the plane.
Oh, thank you, Gerd. You are very kind. Thank you.
So your speech very fast.
Thank you. But if someone have any questions, we are available, me and Gerd, to answer your questions. And we also want your participation on the blog. You can.
Flavia, let's talk about the Van Allen best, the Van Allen best theory. Do you know?
I didn't understand which kind of theories.
Best, Van, Van Allen belt.
No.
Yes, it is. So go, go, go to the page. Preexercise.com and
On Facebook.
no, on the website,
The blog.
the website.
Okay. I'm here.
It's not the blog anymore. It's
Oh,
more than blog. It's a website. Now
oh,
we moved to we moved to WordPress.
okay. I'm here.
Share the desktop.
Where? On the page.
Go 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 down. Go down to
Oh, I like the picture. You
which
put,
which one? Which one?
oh, our pictures, yours and mine.
Which which one? Which
Yes, I'm
share.
down. I'm at the bottom of the page.
Okay. No. Go to the exploration category.
Exploration. Uh, I can see here home, astronomy, science, lifestyle, environment.
No, no. Go down. Go down.
Go down. Okay. Uh,
Share. Share. Share
okay,
the
I will share
desktop.
the
Share the
page.
desktop.
Okay.
Okay. So go up. Move. Move up, please.
Here?
Up. What is the no. Go back.
Here?
Go back. Go back. Go back. Go into home page.
Oh, home.
Okay. No.
Okay. Here.
Okay. Go down. Go down. Go down. 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 Page two. Come on. Advanced.
Which one?
Down.
Down?
Come on. No.
Here?
Yes, one
This
bell.
one? Did Van Allen Belt stop the moon landings? Oh, I'm
Do
not
you,
I'm not updated with these. Uh,
do you
can you
know
explain?
about?
Can you explain to me about this?
Yes, of course. It's physics. It's physics.
Okay.
The Van belt are, are the place where the particles collect during due to the magnetic field. Um, the it's it is composed into parts. The outer the outermost are collecting the the, the electrons and and they are not so dense, but the inner part are, are, are collect the protons and it is uh, denser respect to the the out the outest the outest shell. So there is a theory. There is a theory which states that no one, no one can pass through those those belts.
Oh God.
Uh, yes, but it is just a conspiracy theory, and but it is stupid because uh, there are few ways to go over the belt. Um, one is moving fast, and the second way is to shield the the equipment and the human beings.
Oh
For
God.
example,
But just using the gravity is impossible. You need
yes,
to use the propulsion of the aircraft to help.
yes, of course.
Okay.
And let me say that uh, the amount of radiation you can take if you if you if you fly by a plane. If you fly by a you can get the same amount of radiation like you get when you take a scanner in the hospital. So
Oh,
it is not dangerous. It is it isn't dangerous. Uh, of course, the radiation is danger for electronic circuits. Yes, but in today, in today technologies, if today's we we improved the shields the shields of the equipment, but many people believes that no one can pass through the banana belts. Did you know, Flavia? Did you know?
It reminds me Bermuda Triangle.
Hmm.
Have you heard about
Bermuda.
Bermuda Triangle? The that conspiracy theory that all the ships disappear when they need to cross the Bermuda Triangle.
Do you ever travel inside
No, no.
you you are afraid of disappearing?
Yeah, I believe this is the same
Yeah.
on the space, not on the ocean, but the deep space. I believe is in the is this process in the Earth orbit or on the deep space? This phenomenon,
I, I, I think in the
deep
deep
space.
space.
Oh, it's very interesting.
Or yes, I, I will collect many of those theories, those conspiracy theories, because they are easy they are easy to debunk. They are very easy to debunk. Many, many of conspiracy theories are very easy to debunk. Uh,
You need to write
logic,
about the Bermuda Triangle. I believe it would be very interesting.
yes, I, I will in the future. Uh, I will write some posts about Bermuda triangles. It's a very eradicated belief. It's a very massive belief. Yes, you gave the right idea, Flavia. Mhm.
That's very nice. I'm looking forward to read your post about that.
Yes, yes. So, any any question about if not, we can just make other posts about the Artemis, about the Artemis mission, and maybe Flavia, maybe we will do another live, and we will see the landing of the Orion, the landing.
Oh, it will be amazing. We follow all the mission, and
No,
this
no, no,
moment,
we will follow the landing.
the coming back of the mission, it will be very
Yes,
exciting.
of
But
course.
the re-entry moment on the atmosphere or the landing on the Pacific Ocean.
It, no, because communications should shut down because of the energy of coming back, of closing the atmosphere. So it is possible to communicate during the coming back. And during the crossing the atmosphere. But
But
when
maybe NASA can get some images or videos of this moment and
yeah,
follow.
uh, yes, the landing is expected to be on Pacific Ocean.
Yeah.
I will I don't know actually where exactly, but it is expected to near the Mexico or I don't know.
Oh, close to US.
Yes, close to US.
Oh, that's nice. We can make some a live and try to be
Of course,
present.
yes. With Mitch,
Yes,
with
Matthew. Yes, he knows a lot about rockets. I believe
yes,
he can describe the re-entry of the Orion spacecraft and describe the shield, the heat shield. How is this process?
yes. I think he's very prepared about rockets and about space space trips. And I I don't know, but in a few days we will make a video about moon trips. Uh, my friend Marcel will make a video about moon trips. He he will talk about the Apollo missions. He will talk about lunar missions, the Soviet missions to reach the
Hmm.
moon.
Gerd, we can talk about Yuri Gagarin's mission also to make some kind of
Yes, yes,
to recover this Cold War moment, and we could investigate more about China mission, because they are doing some kind of exploration by alone.
Flavia, you you said that China is working alone.
Yeah,
No, no, China is not alone. China is but in partnership with Russia, with Russia, they they have a project to go on to the moon together. Kiss China and uh, Russian Russian
Russia.
Federation. Yes, so
We
uh,
could talk about that, because I believe there is some kind of competition between
yes, of
China
course,
and US.
you know, Flavius, we are in a second Cold War.
Yeah,
We are in a second Cold War. The Soviet Union felt Russia is the upcoming super, superpower. So, Cold War ends in the 89, but I, I, I believe that the Second Cold War will be longer, even longer than the first. Uh, of course, there are many differences between uh, first Cold War and this Cold War. Uh, if, if that means the competition in
yes, but
AI.
it's very sad they use the competition to improve progress. It would be a natural process, not a competition. Uh, but what make me very happy with this mission, and we could explore more and make some kind of live or post, is about the astronaut, the female astronaut, the first woman to go to the moon. I
Yes,
think it's amazing. We need to know more about her, her hobbies. I read that she like yoga. She likes to climb and like to practice yoga. So I think she's an amazing woman, and we need to explore more her background.
Flavia, the world changed a lot. Changed a lot. For example, in the 1972, no woman astronauts in NASA. Now it is normal to have a woman, a female astronaut. And we are proud. And we are proud to do this because the, the, the natural progress, the natural development of of the humanity,
Yes.
the progress of the equality between men and humans and women, uh, who who deserve to be deserve to be there. So it is a kind of progress that we we have to be proud.
We need to celebrate this milestone.
Yes, we have to be very proud of this kind of progress of human development. We need to celebrate it. We need to celebrate it.
Yeah. Yes, definitely. And the Afro-American also, the pilot.
Yes. The minorities. The minorities.
They were represented in this trip to the moon.
Yes.
It make me very happy about the mission.
Yes. We are multicultural. We live in a multicultural environment. So why a black astronaut cannot lift off? Why? Why white people should have this privilege? Why? Every, everyone is the same. Just
We are just stardust. All of
yes,
us will go back, come back to the stardust.
Claudia,
And
we live in the same land, in the same planet. Of course, me and you, for, for example, me and you, there are many differences. Well, there are cultural traditions difference, but uh, we, we have the same interests, the same knowledge, the same way to understand the needs, the same way to watch the world, and this and those makes make our difference very close, very short. And why? Because I, I told you before, we live in just the same planets. and we have respect to each other. Um, of course, of course, French is something like that. But the most important is the respect.
Yeah.
We
I
don't
can. I
unite.
believe. I believe if we don't agree with other person, for example, I don't agree with you in some idea, but I will respect your perspective, your point of view. The problem
Yes,
nowadays is people don't respect the opinion of the other person.
yes, yes. As I told the judge, we have many differences, but if we respect each other, the difference uh, reduced, will reduce. Even if there are differences, but if we respect each other, it is okay. It is okay. So, Flavia, what, what do you what, what do you want to do now?
We can finish the live. Thank
Okay.
thank all the audience for participating with us
Yeah.
on this discussion because it was very amazing and very rich discussion.
Yeah.
And we can invite everyone to participate in the next live about Artemis 2 landing.
Yes, of course. Of course. I, we are inviting all of you, and we will set up a Facebook events. Uh, I have set up a Facebook events to notice the audience about the live. So let's finish now and wait a moment. Wait a moment. Wait. Okay, bye. Wait. Mm.